Okay, so we'll begin this course on data structures and algorithms by talking about arrays. Hooray for arrays. They are probably the most common data structure. They exist everywhere. They're the backing structure for a lot of other things we'll talk about later in this course. Most people have used them before, and almost every language has a default implementation of an array. Although that might vary, for example, between JavaScript and Java. An array is it's a concept. We're going to talk about an array as an abstract data structure more so than as a specific implementation. And so essentially what an array is it's a list of items. So a shopping list is a good example. I want to go to the store. I know I need, fruit for my party. So I'm going to get apples, oranges, and pears. Well, if I'm going to store that somewhere, I might write it down, maybe in a bullet point list. I'll add these bullets. Otherwise, it's just a regular list, which everyone knows is not nearly as important as a bulleted list. But that might be an example of why I would want to use an array. So this is a good example of what an array might look like. We have this big block here, and in this block we want to put our three shopping items. We're going to put apples, we're going to put oranges, and we're going to put pears in each of these three spots. So we could also maybe do something like this, where we essentially just say 0, 1, 2, because we start our arrays at 0, like most things in programming. That's how we begin counting. And so that's it. We have an array, and it has three items in it. And so fundamentally, this is what an array looks like. There are some differences about, depending on how an array might be implemented. Some people might say it needs to meet certain restrictions, which we'll talk about in a second. But essentially, an array is a list. It's a sequence of values that you can add to and access by referring to a position, one of these guys, a position in the array. So for an array like this, which is let's get a brighter color. Something that is, n items long. Well, how many is n? Well, it's just how many items are in the array, or how many spaces in this array are allocated for items. We'll talk about that distinction a little later. In this case, it's 10. So our n is 10, and so this array ranges from 0 to n minus 1 or 9. So 0 to 9. Those are the bounds of this array. So we talked a little bit about restrictions. Let's talk a little bit about how you define an array. So we have our original array here. This is one simple definition that I like. An array is an ordered data structure. Ordered here means that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They're ordered. Now, we might have an array like 1, 2, 3, and it's important here to realize, okay, 1, 2, and 3 are the items in the array. 1, 2, 3, like that. But I refer to them by their indices. So if this is my array, const a equals an array, then a at the 0th index is going to be 1, and then a at the first index is going to be 2, and so on. Ordered here means that the items are ordered by their keys or their indexes or indices. It does not mean sorted. So 3, 9, 78, 4. This is also an ordered array here. It's not any less ordered than that other one, because ordered means the items in the array are arranged by their indices. It doesn't mean that it's sorted. Let's look at a little broader definition here. An array is an indexed collection of data elements of the same type. Same type is interesting. So indexed and ordered in these two definitions are saying the same thing. So an array is indexed. These are the indices. Or ordered. Same thing. Indexed or ordered. Collection of data elements of the same type. Well, what does that mean? Well, here it means that, well, we can't have, for example, a string like hello and a number like 1 or 2 or 3 in the same array. So that's something we're going to talk about because, you know, if you've been programming with JavaScript a little bit, you know that's not true. You can have an array with all kinds of different values in it. It doesn't matter. They're not restricted by the type. But there is a reason, obviously, why this point here is made. The restriction of the same type is an important one, they even say, because arrays are stored in consecutive memory cells. Haven't said anything about memory cells. Every cell must be the same type and therefore the same size. We're going to talk about what this means here in the next video. And that's where we're really going to get into the meat of it, with the difference between static and dynamic arrays. But for now, all you need to remember is an array is an ordered data structure, very much like our list.